Hey everyone! Today we're going to break down one of the most important pieces of modern backend architecture, the API gateway. If you've ever wondered how big companies like Netflix, Amazon, or Uber handle millions of API requests, this is the answer. Let's dive in. So what exactly is an API gateway? Think of it as the front door to your entire backend system. Every single API request from your clients, whether it's a mobile app, a web browser, or another service, goes through this single entry point first. It acts as a reverse proxy that routes requests to the right microservice behind the scenes. Without an API gateway, your clients would need to know the address of every single microservice. Imagine your mobile app making separate calls to the user service, the order service, the payment service, and the notification service. That's a nightmare to manage. Each client needs to handle authentication, rate limiting, and load balancing on its own. Now, with an API gateway, everything becomes clean and organized. All clients talk to just one endpoint, the gateway. The gateway then intelligently routes each request to the correct backend service. It's like having a receptionist at a big company. You don't need to know which floor each department is on. You just tell the receptionist what you need, and they direct you. The API gateway is really the central nervous system of your microservices architecture. It connects everything together and handles cross-cutting concerns like authentication, logging, and monitoring. Services orbit around it, each handling their own domain, but the gateway is what ties them all together into one cohesive system. An API gateway comes packed with powerful features. It handles request routing, deciding which service should process each request. It does authentication and authorization, verifying who you are and what you can access. Rate limiting prevents abuse. Response caching speeds things up. Load balancing distributes traffic. And protocol translation lets different clients speak different protocols. Let's walk through what happens when a request hits your API gateway. First, the client sends a request to the gateway endpoint. Then the gateway authenticates the request, checking the token or API key. Next, it applies rate limiting to make sure the client hasn't exceeded their quota. Then it routes the request to the correct backend service. The service processes it and returns a response. Finally, the gateway may transform or cache the response before sending it back to the client. Looking at the full architecture, the API gateway sits right in the middle. At the top, you have your client layer, mobile apps, web browsers, and third-party integrations. Below that is the gateway layer handling all cross-cutting concerns. Then comes the service mesh where your microservices communicate. And at the bottom, your data layer with databases, caches, and message queues. Here's what a simple API gateway configuration looks like in practice. This is using Express.js with a popular library called Express HTTP Proxy. We define routes for each microservice and proxy incoming requests to the right backend service. The gateway adds authentication middleware and can transform requests and responses on the fly. When it comes to choosing an API gateway, you've got some great options. Kong is one of the most popular open source gateways built on top of Jinx. AWS API Gateway is the go-to for serverless architectures on Amazon Web Services. Traefik is perfect for containerized environments with automatic service discovery. And Apigee by Google Cloud offers enterprise-grade API management with advanced analytics. The difference is massive. Without an API gateway, each client manages its own connections, auth, and error handling. You might see latency spike by 3x or more as clients make multiple round trips. With a gateway, a single optimized connection handles everything. Studies show up to 60% reduction in client-side latency and dramatically simpler client code. And that's API gateways explained. They're the backbone of any serious microservices architecture. If you found this helpful, smash that like button and subscribe for more tech deep dives. Drop a comment below telling me what topic you want me to cover next. See you in the next one.